In this video, we are discussing standard deviation. We'll start with an example. Find the deviations from the mean for all data values in the following sample: 32, 41, 47, 53, and 57. So the first thing we need to do is find the mean. And here, x bar is 32 plus 41 plus 47 plus 53 plus 57, all divided by 5. That's 230 divided by 5, which is 46. Then the deviation from the mean is the difference between each value and the mean. So the 5 deviations from the mean are 32 minus 46, which is negative 14, 41 minus 46, which is negative 5, and then we've got 1, 7, and 11. Note that the sum of the deviations from the mean for any data set is 0. So for example, negative 14 minus 5 plus 1 plus 7 plus 11 is negative 19 plus 19, so that's 0. This means the mean of the deviations is also 0, so it has no significant value to us. To avoid the problem that the positive and negative values cancel each other out, we square each deviation because the square of any number is positive or 0. So the data values are 32, 41, 47, 53, and 57. We've got their deviations, and then we square each of those deviations. So 196, 25, 1, 49, and 121. Oop, I got an upside down page here. We could take the average of the squared deviations by dividing their sum by the number of data values, n, which is 5 in this case, which we would do if our data values composed a population. Since we consider the data to be a sample, however, we divide by n minus 1 instead. The average that results is a measure of dispersion called the variance, but a more common measure is obtained by taking the square root of the variance. Taking the square root compensates for squaring the deviations earlier, and this gives a sort of average of the deviations from the mean. This is called the sample standard deviation. It is denoted by the letter S. The standard deviation of a population is denoted sigma, the lowercase Greek letter. So continuing our calculations, we have S equals the square root of 196 plus 25 plus 1 plus 49 plus 12 divided by 4. That's the square root of 392 divided by 4, which is the square root of 98, or about 9 91/100ths. So to calculate the standard deviation, we let a sample of n numbers, x1, x2, up to xn, have mean x bar. Then the sample standard deviation, S, is calculated by S equals the square root of the sum of x minus x bar squared all over n minus 1. The individual steps are as follows. First, calculate x bar, the sample mean. Then find the deviations from the mean. Square each deviation. Add the squared deviations. Divide the sum in step 4 by n minus 1. And take the square root of the quotient in step 5. So for example, find the standard deviation of the following sample: 7, 9, 18, 22, 27, 29, 32, 40. So first we find the mean of the sample, which is 23. Then we find the deviations. Here they are. Negative 16, negative 14, negative 5, and so on. And we square each of them to get 256, 196, 25, 1, 9, 36, 81, and 289. We add up those squares. They add up to 900. We divide them by the number of elements in the sample, minus 1. That's 900 minus divided by 7. Is about 129.57, and then we take the square root, and that gives us about 11.3.